Thanks for taking the time out to join the call. Today, we have Raj and Stefan from Sophis. My name's Sylvie Dubois. I'm with CGIS. If you want to go to the next slide there, Stefan. So CGIS is hosting this with our partners Sophis. CGIS's vision is a world without valve problems, which is one of the reasons why we partner with a great company like Sophis, who's going to take us through some unfortunate incidents that occurred in the industry and some preventable systems that can help us work through some of those challenges that had happened. So something to be a little bit hopefully people take away some learnings here today and can deploy some of these systems out in their on their end user sites. Just a little bit of housekeeping if you want to go to the next slide, Stefan. So if you're not familiar with Zoom, some of us are not, we tend to work in teams. If you guys could put your questions in the Q&A section, so down in the ribbon, you'll see one of the buttons is Q&A. So we will be answering questions through the presentation, but only direct to the person who's asked it. And then after the wrap up of the webinar, what we'll do is we'll take some of those great questions and pose it to the group and just share some of the key learnings that those people have gotten from either Raj or Stefan or Braden, who's also on the call. So just to keep things moving along and make sure we're on time, as mentioned, please put them in the Q&A portion and we will address them as a group later on if we have time. So from here, Stefan, Raj, take it away.
Thanks, Sylvie, for the introduction and give us a chance to present some nice incidents. Well, the incidents haven't been nice, but give us a chance to introduce the incidents and to showcase what can be done to prevent such incidents in the future. First of all, the purpose of Sophis is to protect the people, the property, and the planet with our experience and the solutions to guarantee safe and efficient valve and manual valve operations. First of all, no injuries, no accidents, no spills, no loss, no downtime. In today's webinar, after a first introduction, I want to give you a short overview about the captive key system. And then I will introduce the US Chemical Safety and Hazard Investigation Board. And then I will jump over to the first incident at a refinery in Louisiana, followed by the second incident on MGPI processing plant in Kansas. And then afterwards, we will have the Q&A. My name is Stefan Sadowski. I'm the head of business development at company Sophis. My background is mechanical engineering, and I'm now over 27 years within this business. Sophis is a manufacturer and provider of individual captive key and valve operation solutions for the process industry. Our strengths are the adaptation of the customized solutions for the seamless implementation into the existing infrastructure of our customers. Sophis is a merger of the both companies, interlocks and Smith Flow Control, and the merger happened in 2016. Sophis is part of the Halma company. The Halma company is a global group of life-saving technology companies split it into several sectors. Sophis is part of the safety sector. Halma was founded in 1894. First time I thought, oh, might be a typo, but no, that's true. Halma began as Halma Tea Estate Company Limited, focused on rubber production and tea planting in Ceylon. Nowadays, we are over 45 companies under the umbrella of Halma, and we are around over 7,000 employees, and Sophis is a part of Halma. When we are talking about captive key lock or interlocking, which are both very familiar phrases, then we need to be careful. We here in Europe, we most likely use the phrases interlocking. And but as more we get confronted with other departments like instrumentation team, their interlocking has a different meaning. Therefore, we need to take care about the phrases. Today, I will talk about captive key systems, which is a mechanical way to interlock valves and guide operators through a specific sequence of operations. Interlocking on the instrumentation part means a kind of electrical interlocking of signals and actions against each other. And therefore, we need to be careful about the different phrases. If we talk about process safety, and sequence control, there I want to showcase on some small examples what are the different safety principles versus their investment costs. What we can see here on the slide, the lowest level of safety and also the lowest investment cost is provided with written procedures, followed by lockout-tagout. Then there are some individual solutions which are used in the industry to guarantee the safe operation and safe sequencing of valve operation. Then we have actuated, fully automated systems. There we have a much higher safety level, but also a very high investment cost. And then with the captive key system, we have still a higher safety level with a lower investment cost. Let's look into the written procedures. Written procedures are a common way to ensure that operating tasks are performed correctly. The magazine research at Texas A&M mentioned that within the last 2 decades, 49 of 100 incidents in the oil and gas industry include some kind of procedural errors. And this is also what you can see in the 2 incidents today. What we also can see, written procedures tend to be ambitious, complex, and requires time by time judgment or decisions from the operators. And this is definitely something we want to prevent. If we now jump over to lockout-tagout, in a more general definition, lockout-tagout is a procedure used to isolate hazard energy sources to prevent accidents during servicing or maintenance. For the process industry, it is common to use this method to prevent, for example, valve operation. Valves that should be blocked in an open or closed position because of the process get equipped with car seals, hand wheel covers, or similar blocking solutions. Therefore, a clear differentiation between the 2 different ways of use is necessary. The main challenges are lack of procedures, what we touched already before. Also, the training of the employees is an important aspect and should not be underestimated. From our own experience, we know that there is a lot of room for improvement by using lockout-tagout. Online training becomes more and more a useful tool. The use of the right tags and padlock is also a very important aspect within lockout-tagout. Therefore, it should be clear procedures in play, or therefore it should be clear to have procedures in place to separate the different ways of use. As already mentioned, it is very common to use this method to prevent valve operation. So This is a method you can use for boundary valves or not really safety relevant valves where you want to have a dedicated sequence of operation. If we now jump over to the individual solution, here on the screen you can see a PSV system with 4 PSVs with inlet and outlet valves. And the safety aspect here is that you want to guarantee that all the time 3 of the 4 PSVs are in process. So the PSVs are redundant, and therefore the customer put this steel construction in front of the valves, and so they can guarantee that you have to open these both inlet and outlet valves first before you can start moving this bar, bring it in front of the next PSV system, and close the inlet and outlet valves. But also, this solution has a safety risk, but I will pick this up later in the first incident of today's webinar. The disadvantages of such solutions is you have to bring all the valves to the same level because there are welded flex in front of the stems. So this requires already design impact. There is a lot of steel work required in front of the valves, so this will also hamper the operator to operate the valves on a proper way. The large sliding bar is difficult to handle, and yeah, it's a space-consuming design. If we look to full automated systems, this is definitely a solution, but also there you need to take care about the existing infrastructure. To retrofit actuators in a brownfield plant is always a challenge. You need to have the cabling in place, all the signals and everything else. So this is might be an option for greenfield projects, but not really for brownfield projects. If we look now to the captive key systems, this is a fully mechanical solution, and it will guide the operator to the unique sequence, which will be adapted to the process requirements. And to guarantee the right sequence of operation, we are using unique coded keys. There is no misinterpretation on the steps possible because you have the coded keys. We are also able to handle even complex processes on a safe way, even if they are not linear. It's easy to retrofit on every type of valve, even in brownfield projects. And it can also involve all kinds of equipment. Doesn't matter if you have valves, actuators, or pick trap doors, or what else. No additional infrastructure is required, and yes, you need some kind of training for the employees that they understand how to operate the valves in the right sequence. The LOPA handbook described also the use of captive key systems. In the LOPA handbook, it's described as an independent layer of safety and will give you some credits in your HACCP. And the description of the captive key system is that it is an mechanical linkage between the valve and using unique coded keys to prevent movement of a device such as door, handle, or valve. This prevents humans from operating the valves in the wrong sequence. The captive key lock capability is an integral part of the hardware design. So the captive key lock needs to be one part with the valve. So there is no chance to separate both during normal operation. Now let's have a look to the incidents. What I do is that I continuously review the reports from CSB, which is the US Chemical Safety and Hazard Investigation Board. They do a really great job by investigating on chemical incidents. And the CSB is an independent federal agency. And if you haven't heard about them or haven't seen their website, it really makes sense to visit them and have a look to their website. Let's start now with the first incident. At the 10th of April in 2020 at the Valero refinery in Louisiana, there was a release of a mixture of hydrogen and hydrocarbon gases, which in the hydrocracker unit, and these gases formed a flammable vapor cloud. This cloud got ignited and resulting in an explosion and fire that seriously injured one of the Valero operators and caused damage of over 5.15 million in property. What happened? The root cause was that after a heavy rainstorm, the flow of the hydrocracker unit flare began to increase. And after some investigation, they figured out that the emergency pressure relief valve had a malfunction and remained stay open. Common practice at Valero refinery was the reseating of the safety valve, and this process needs to have the approval from the plant manager, and this approval was ordered and got approved from the plant manager. And then the two operators went on site to the safety valve, and they had concerns to reach the 6-inch inlet valve, because the procedure told them you have to close the inlet valve partially till to the point when the safety valve will be reseated, and then you open the inlet valve again and hope that the safety valve will stay in a tight position. So the operators could not really access the 6-inch inlet valve. Therefore, they decided to close the 20-inch outlet valve. What was the result? If we look to the design specifications, then we can see the 6-inch inlet valve was designed for 2,470 psi. And the outlet valve, which was a 20-inch valve, was only designed for 275 psi. And after they closed the outlet valve by around 90%, then the valve failed. So this ended up in a releasing of a high pressure mixture of hydrogen and hydrocarbon vapor into the surrounding air. And the flammable gases formed a vapor cloud, and this got ignited and resulted in the explosion and in the fire. How could this have been prevented? By the implementation of a captive key solution, this incident definitely could have been prevented. The captive key solution requires the involvement of the inlet and the outlet valves, and this guarantee that the outlet valve cannot be overpressurized. And it also will guarantee that you have a continuously pressure protection of your equipment. If you do a changeover between a redundant PSV system, then you have to bring the standby PSV in process before you can start isolating the other PSV system. And this will guarantee also the overpressure protection of your equipment upfront, the PSV systems. If we look to typical specifications in the industry, then we can see here this setup. We have here the redundant PSV system with inlet valves and with the outlet valves, and which goes to the flare system. Most of the time, we see that our customers only interlock the inlet valves. So to guarantee that all the time one PSV is in process. So in this case, you have to open first the inlet valve of PSV B before you can start closing the inlet valve of PSV A. And on the outlet valves, they most of the time put lockout tagout devices to block the valves in an open position. But this is an unsafe situation. We recommend to use this kind of setup where you interlock the inlet and outlet valves. So in this case, you have to close or you have to open the inlet valve first before you can close the inlet valve of safety valve A, and then you can start to close the outlet valve of safety valve A. This is a typical example of a captive key solution for a redundant PSV system. Here we see the CKC, which is placed. CKC is the control key cabinet. The control key cabinet is placed in the control room. Starting with key 1 coming from the control room, the operator will place the key in the inlet valve of safety valve B. Now he can start operating the valve. He will open the valve, and after the valve is fully open, he can release key 2. And with key 2, he can go now to the inlet valve of PSV A, insert the key, close the valve, and after the valve is fully closed, he can release the key 3. And with key 3, he goes to the outlet valve, insert the key here, close the valve, and release key number 4. And now the PSV-A is fully isolated and can take out for maintenance purpose, like reviewing the PSV or whatever. And with this kind of solution, we guarantee that all the time one PSV is in process, and we also guarantee that you cannot close the outlet valve before the inlet valve is closed. So this will give a protection, overpressure protection also to the outlet valve. What are the key features? Safe operation of a redundant PSV system, which guarantee the protection of the equipment up front. We protect the outlet valve against overpressure. A clear indication of the isolated PSV by the end key in the control room. So you can use the information coming from the key to make your work permits, because the key will indicate which PSV is isolated and which PSV is in process. There's also the option for the easy implementation of pilot valves. This is also an important aspect. If you have a pilot-operated safety valve, there you also need to implement the pilot valve into this sequence of operation. And last but not least, there's also the option for cascading of redundant PSV systems to prevent chattering, for example, of PSVs in case of actions. Let's jump to the second incident. The second incident happened at the 21st of October at 2016. At MGPI processing plant, which is placed in Kansas. At the accident, there was an accidental mixing of incompatible components, which have been sulfuric acid and sodium hypochlorite. This produced a cloud containing chlorine and other components. The cloud impacted workers on site and members of the public in the surroundings community, what you also can see here on the picture. On this picture here, you will see this is the location where the unloading and offloading happened. This is the plant, and here you have the surrounding public areas which have been impacted also by this incident. Here you have a more detailed overview. There is the mod building where the operators are normally placed. This is the unloading area, and where the truck drivers connect their hoses and unload the chemicals. This is how it looks like at the unloading point. And what happened at this day? The truck driver arrived early in the morning, and the operator from the night shift was present, and he accepted the delivery of the 30% sulfuric acid. And then the operator escorted the truck driver to the unloading area. And at the unloading area, the operator unlocked the gate in front of the transfer equipment and removed the lock, the padlock, which have been on the cam lever dust cap for the sulfuric acid fill line. But the truck driver was at his truck and has done some paperwork at this time. Then at the later stage, the operator reports that he pointed to the line of the sulfuric acid, but the truck driver reported, no, the operator didn't point it to the fill line. So what happened afterwards? The operator returned to the mod building, and the truck driver started to connect the hoses to one of the unlocked fill lines. And by accident, he connected the hose to the wrong line, and started with the unloading process. After the truck driver checked if there have been some leakages at the hoses. The result was that the sodium hypochlorite fill line was unsecured and therefore accessible for the driver. He unloaded around 4,000 gallons of sulfuric acid into the sodium tank, which has around input of around 5,850 gallons. And these both chemicals reacted and produced a theoretical maximum gas cloud of 3,490 pounds, which have been a mixture of chlorine gas and other gases. These gases have been released through the 3-inch atmospheric vent valve and the 80-inch lid of the roof of the bulk tank. And what you can see here from the picture is a gas cloud which moved across the facility and to the public area. How could this incident have been prevented? There are several options. First of all, you can use 2 different fill line sizes, or you can use different shapes for the fill lines. What also missed is that was missing at the site a clear indication of the fill lines. Another option would be to put really specific cages in front of each fill line so that you guarantee that only one fill line is available for the customer. Another option would be to implement the Sophis Silox solution. How does the Sophis Silox solution works? When the customer recognizes that he needs the refillment of one of his products, he will place a PO at the supplier. And with the PO and the delivery note, there will be a QR code printed on the delivery note. The truck driver arrives on site and then he hands over the delivery note to the operators or to the security. And the security starts to scan this QR code at our Silox solution. And the Silox solution registers which product is loaded on the truck. And then the system decided which key needs to be released. And this key will be highlighted. The security person will release the key from the cabinet and hand over the key to the truck driver. And now the truck driver will drive to the loading base. At the loading base, all of the loading lines are equipped with a captive key lock. So the truck driver will connect his hose to the loading point, and after the hose is connected, he will insert the key, and only this key will fit to one loading point. So you can guarantee that there is no mix-up of the products. Now he is able to open the line and unload the product. After he has finished the unloading process, he will disconnect the hose again. After he closed the valve, he will release the key, and with the key he goes back to the security, hand over the key, and job is done on a safe way. What are the benefits? We are fully eliminating human errors during the fill line selection process because of the unique-coded keys. We have unique-coded keys per silos. There are also the option to group silos. So if you have the same product in several silos, then you can set up the same key code for these silos. There's also the option to interlock silos against each other. So if you do not want that the filling process will be done on several silos at the same time, also this can be realized with this solution. And there's also the option to provide furthermore information to the SCADA system to showcase which silo will be unload or will be filled at the moment. And last but not least, there is also a connection possible to the DCS system for the interaction with other components, like with a pump startup or whatever. So that's it so far from my side. Are there any questions?
And just a reminder, you guys can go ahead and throw them into the Q&A section. Stefan, we did get a couple questions in the Q&A portion that I think Braden is going to want to bring up and address. If you could, please.
Yeah, sure. Sounds great. Yeah, some great questions already popping in here. So the first one, Stefan, was on the example of the Valero accident. What avoids the operator from going or skipping valve 2 and just going from valve 1 to 3?
Each key is unique coded, and for each step you will have a different key code. So you cannot mix up the keys. So the operator has to insert the first key. When both keys are inserted, he can now start to operate the valve. And only when the valve is, for example, fully open, he can release the second key. And this second key will only fit on the next valve. And after the valve left the one position, the other key is trapped. So the keys are trapped against each other. The keys are Unicoded, and therefore you build up this sequence. And this will prevent a mix match of valve operation.
Fantastic. And similar, but an interesting opportunity here. So this question was, in a manually operated water pipeline system with multiple drainage points, some designed for full pressure packed line drainage and others for local low pressure section. What kind of physical interlock mechanism would you recommend to ensure operators always drain through the main high pressure rated valve first before operating the secondary low pressure ones? Have you any experience on that type of system before?
If I understand it right, then yes, it makes sense to depressurize the high pressure first and then the low pressure, and equip these valves with captive key locks too.
Great.
So that there is no chance that you can depressurize at the same time, because then you would have a kind of pressure increase on the low pressure side coming from the high pressure side.
Right. And I think one of the other considerations in the question here too was, is there an opportunity to create a time delay, or have you ever done it where you've, like, that's a mechanical connection, but is there a way to tie the key system into like a pressure gauge or
Yes.
a time delay that would allow for that first valve to open, drain it, get a key out, but not be able to operate this low pressure valve until the pressure hit a certain system with pressure within the
Yeah,
system? Is it possible?
this is no problem at all.
Okay.
First of all, the captive key system is a full mechanical solution, but it is easily possible to integrate also electrical signals into this kind of sequences. For example, the operator will not be able to release the second key until a certain pressure level is reached. So you can connect or you can use the information from pressure transmitters to unlock the keys. Therefore, we are using our electrical key cabinet, which has a key position equipped with solenoids to trap the key, and also with limit switches to indicate the present and the absent of the key. So the solenoid only can be energized until a certain pressure level is reached, and then the operator can release the key and start with the depressurization of the low pressure line. And there you can use all kind of electrical signals. Doesn't matter if this is pressure, temperature. It's also possible to put in a time delay or other aspects. This is also what we are using to implement, for example, electrical actuators in such mechanical sequences. There we are using the feedback information from the actuator about the open and closed position of the valve to trap or release keys. And when one key is missing, then the actuator is trapped and cannot be operated anymore. So
Okay.
the sky is the limit.
Yeah. Perfect. And do you normally see in those systems with the I guess the initial start key would be in a control room or something like that, and then the sort of the secondary, the third, the different steps, maybe the cabinet may be out actually in the process area. Is that usually how it happens?
Yes.
Yeah.
There are also all options possible. Also, the cabinet in the control room can be equipped with limit switches and solenoids. We also, if you have larger systems or the control room is far away, and then we also can use our key management system to track and trace the use of a larger amount of keys. So there's also a very good reporting functionality implemented. There we also give the operator an overview about the sequences and furthermore information. So what I said before, the sky is the limit. Whatever problem you have, reach out to us. And it's not only linked to valves, what I mentioned before. It's we can implement all kind of equipment. So if you have a railway section with unloading, offloading, then we can implement barriers, doors, pick trap doors, which is a very common application.
Perfect. Great. Some other questions come in here. So in the second example, what check is in place to ensure that what is in the tanker is indeed the correct chemical per the label MSD? So tanker says it's H2SO4 being delivered. Is there a way to confirm that before it gets hooked up, or any recommendation on that, or?
Yeah, so there are two bits to this one. One is that the supplier themselves are legally also responsible to have the right chemical in the tank per the bill of lading, because that might cross border checkpoints or it could cross state lines or whatever. So they are responsible as well. But the second thing is, even before loading starts, it's possible that there is a quality check. So let's say there is a pharma company that's receiving product, or even oil companies receiving products. There is a quality check that would happen that would not just check what material that is, but also if that matches to the specific grade. So depending on the criticality of what chemical is arriving, that is also part of the receiving process. This typically, the problem that we are trying to solve is much downstream of that. When the chemical is now at the silo loading points, there still are opportunities to mess that up, because what we've seen typically in our experience is even just the silo loading points just closed with the cap and not even having a padlock on them. So it's pretty much accessible to anyone coming in with a truck to just open one of those points and connect their hose to it. So it's that problem that we are solving for, whereas this problem is dealt with in two ways.
Awesome. Perfect. Thank you, Raj. All right, a couple more questions here. How is the sill lock integrated with the SCADA or DCS system? Is it dry contact or?
It depends on the requirements.
Okay.
So we are luckily in the position that we can solve things individually. This is one of our strengths. The build up individual solution for the seamless implementation into the existing infrastructure. And this is also where we are coming from, because if we want to add the captive key locks to existing valves, also there adaptation is required. So we design the bracket and adapters necessary to mount the interlocks of the onto the existing valves. And this mindset we have across all our products. So everything is individual. It's not a product out of the shelf. It's an individual solution customized.
I see the next question being, it's designed for specific set of operations and any change would require reconfiguration. That is partially true. So there will be some configuration change. The key codes might change if the valves are going to be the same, but it might depend what degree of reconfiguration is needed. So let's say your valve itself changes. In that situation, then you might need a new bracket and adapter configuration. I could share my screen very briefly and show what I'm referring to. Do we have time, Braden?
Yeah, perfect. Yeah, no, I was just going to recommend maybe pulling up a couple of the
Yeah.
brochures to show you guys a bit more of the details because yeah.
Um, so I'll just share my screen. Okay, so this is a slide that shows how the product looks like. So this is the body of the interlock. This is what we call an adapter. This is customized to suit a particular valve design. And then this is what we call bracket, which goes around the valve and holds the lock in place. So if your valve itself changes, then this won't fit your new valve. And then we might need to take measurements again and custom design the bracket and the adapter to fit that valve. The lock may still be usable by maybe changing key codes if needed. This is how the locks are coded inside. So let's say if a lock has two key positions in the lock, then we use these mechanical code bars that are riveted to accommodate a certain key code. And these key codes decide how the keys move. So let's say if these two locks share the same key code here and here, the key will then move from this key position to this key position, for example. So depending on how your configuration changes, do we need to rearrange those key codes for the sequence to make sense? If that's the case, then we can do that on site. But otherwise, if the valve itself changes, then we need a new lock. Is the answer yes?
Great. Okay, thank you.
Raj, do you have anything? There's a question about the key management system itself. Do you have
Of
any
course.
brochure just to kind of pop up and give a brief summary on, please?
Okay, I could do that very briefly on this call too. One sec. Okay, is my screen visible?
Yeah.
So with the key management system, I think before I dive into the key management system, I'll show you one more graphic. So the key cabinet that is in the control room that Stefan referred to solves multiple purposes. The first thing is to hold the start keys that start the sequence for each system. So let's say this is a filter system, or you might have a pigging line like this, a pigging sequence like this, or you could have a PSV sequence like this. Everything starts with one key coming out of the control room, which will kickstart the rest of the process, right? So the cabinet does hold the start keys of all the systems, but it also reflects the status of the system on site. And this is done by color coding and tagging the keys and the key cabinet in the correct way. So if let's say this green key is inside, it can tell you exactly what the status of each of those valves in that sequence is, and it can guarantee that for the operators in the control room. What we are trying to do is bring all of that functionality of storing the right keys in the control room, plus giving visibility, plus also managing the administrative control aspect of tracking keys and managing key handouts. So, who gets access to those keys? When did they take access of a certain key? When did that key get returned? What function was achieved using that key? Was a valve status changed? All of these things can be gathered and brought to the same system using a key management product. So, in this situation, the key management system comes with a touchscreen computer and it comes with RFID. So typically what would happen is that an operator would scan the badge, their access badge. They would search for the system that they want to access, and they would toggle the release of that key from the screen. And as soon as that happens, the right key position glows up. You press the push button on that key position, a solenoid triggers the release of that key, and then you can walk away with that key. And what this does basically is it controls who has access to keys based on who they are, and then also gives you all the reporting functionality that comes with key management. So that's the short gist. I can share brochures or or a technical data sheet as required.
We'll just see if the attendee just wants to give us a thumbs up and say if that kind of answered a short version of that. Because if not, we can always follow up with him afterwards. And then also, we've got a hand up in as part of our attendees, but if we could just get you to put your question in the Q&A section, just down in the ribbon, or maybe it's up top. We don't have the availability to open the floor to conversation. So just trying to keep it into the one format, please.
I think there's one more question in the meantime in the Q&A section. It says, captive keys are avoiding human errors but still rely on human interaction and incorrect use. Not really. So
This is
the human... Sorry,
this
Stefan.
is an interesting question, and great thought about it. The operator will be guided with the keys through the ways of operation, and at all the points, even if the operator will stop somewhere in between the sequence, you still have a safe situation. Because you cannot come to an unsafe situation, because you have to do the things step by step. If we go back to the example of the PSV system, even if the operator would stop operations after he opened the inlet valve of the isolated PSV, you still have a safe situation for your equipment. And therefore, it doesn't matter. So the operator is only a kind of tool who went through the steps. You can maybe take an example. The operator is a motor of an actuator. So the programming of the sequence and the locking functionality is done by the captive key lock, and the operator is a motor who is operating the valves, and that's it. So he has no impact on the logic.
Great, thanks, Stephen. I think there's just one more that we kind of want to throw back to you. So, Stefan or Raj, if either of you want to answer it. So let's say we had a captive key, or we had a management system or procedure, a sequence to clean heat exchangers, for instance. So once we're done that process and they've been cleaned and now I've come to the end, how do I go back to the beginning? What's my process to get back to the beginning so we're down or back to running the process as we normally would?
Under normal circumstances at heat exchangers, you have a linear sequence where you isolate first the product line and then the cooling or the heating line, or the way around, depending on the process. And to bring it back into process, you do the same steps backwards. And this is for linear sequences. And if you have non-linear sequences, then this is also possible. And there we have the mechanical process control unit, where you have a kind of mechanical setup of all the steps that needs to be executed. And with such a mechanical process control unit, you can step back and do a lot of steps in between, like for example in picking applications. This is a very common application for nonlinear sequences, where you have to purge and drain and vent several times, and there you also use this kind of mechanical process control unit. And then at the end, after everything is drained and vented and purged, you are able to open the pick trap door to insert your pick or to release your pick.
Awesome. Thank you, Stefan.
I have one last question. I think we've answered most of them, but maybe for Raj, when do you normally get involved with working with EPCs or then users on designing the interlock system on a project?
So, so as Sophis, this is one of our portfolios. We also do portable valve actuators. Um, but the answer from my end is end of feed, detailed design. So when the SP items are to be discussed is when we typically get involved. But my personal recommendation is that we are involved as part of the detailed engineering phase of the project, where once you've built out a sequence of operation for any process, if you identify that there is a risk that the process can be followed incorrectly, someone could deviate from the safe sequence that has been envisioned for that process, and you're like, this could go wrong because someone makes a mistake with the order of operation or when they operate a certain valve. I think that's the best time to reach out to us and be like, can you design a captive key solution for this? And then we can sit with the customer and actually try and identify what constraints they want on the process. So sometimes it might just be, I want to do A, B, C, D in this order. But sometimes it could also be things like, I want a pressure transmitter to be sending a signal to a certain key position that now this is safe to release. And these things, the earlier we discuss it, better, because it also involves conversations not just with the process team, but also might go into piping or instrumentation and control. So, as early in the detailed design stage as possible is better.
I was just curious myself. Pardon me. If all the keys are custom or unique, what happens if one is lost? And are there backups on site? And does that present any risks?
Mhm. So, that's a good question. So, what we do is, of course, we are able to supply spare keys that is sometimes ordered in while the project is being delivered right at the start. But also, what we do is we supply system master keys and master keys. System master keys are keys that can fit the locks in any one system. So if there is a one double piece PSV system, then this one key can act as a master key for that system. But then we also have like master keys that can open pretty much any lock. So these are then managed by the supervisor level hierarchy employees in the operation team, for example. And these are managed separately in a separate cabinet, like a smaller key management system or like a separate control room key cabinet. And in cases of situations like these, you might permit the use of a master key, and that's then used temporarily till Sophis sends out a replacement. And we can make a replacement in a day and ship it out. So that's not a big worry as well.
Gotcha. Thanks.
And along the same lines, a question came in just about if people leave the organization and they need access to the key management system, the reprogramming and updating. That is
We can
something that,
support with all of that.
yeah, okay. So if it's will support that, okay,
Yeah.
fantastic. Another question came in just again, it's 11 o'clock. We'll keep going here for a little bit longer, but feel free to stay on. If not, Sam will be following up with another email. But one more question that came on just came up was I understand that valve and actuator manufacturers will directly coordinate with you. Just talk maybe a little bit about how Sophis works with designing the key systems as well as some of your other um, components with a range of different product lines and brands. I mean, there's really no limit of what you can adapt your components to, correct?
There is yeah, also a very good question, and there is also no clear answer. It depends on the situation, and if we are looking to greenfield projects where everything is new, then it's kind of common standard that we receive the order from the EPC company. And then we stepping into contact with the valve manufacturers or with the valve suppliers and try to get the top work information from the valve suppliers to design our bracket and adapters.
Sure.
There's always a kind of risk because the quality of this information is not always the best. I worked on several projects where we had around 70% mismatch of the data because this has been such a huge project that the valve suppliers collected valves from all over the place, but all of them fit to the specification. And this end up in a problem. Therefore, we recommend that we do the measurement on site. So after the valves are installed, then we come on site and do the measurement. Or if we are looking into brownfield projects, also there's the option that we come on site, do the measurement, or our partners do the measurement, but also the customer itself is able to do the measurement.
And I think just to add to that too, Stefan, so just based on this question, our experience as your technical services arm in Canada, whether it's working with the end users or the customers to go out and take the measurements or providing the sketch to get the actual values related to whether it be the input shaft or the gearbox, depending on what operator we're working with, for the physical properties is one thing. And then obviously with the way that Sophos provides the master sheet to ensure that the sequencing is correct and everybody's in approval or everybody's in agreement before any manufacturing starts. So I think we've really captured any potential risks that happen prior to anything being installed or set up on site. So I think that, in our experience, it's been pretty seamless.
Mm-hmm.
Yep.
Yeah, just to reiterate that Sil is fully trained and capable of going on site. Our team, our service team in Edmonton and BC and Ontario are in that spot where they can assist in making sure that the measurements are correct and so that seamless fit. And we do recommend that we get a service tech out there to really make sure that everything will go together seamlessly. And mistakes do happen sometimes, and we can also fix them if we need to.
Yeah, there are a couple of things you have to take into account when you run such a kind of project. First of all, you need to specify the right sequence of operations. Then, of course, the top work informations of the valves are required, and which is also an important aspect is the tagging of the keys and of the captive key locks, because at the end, the operator is handling the keys, and the keys also should guide the operators through the sequence of operation. And therefore, it does not make sense to have cryptical numbers on the tech plates. So there it really makes sense, if we go back to the example of the redundant PSV system, to say from the control room to the inlet valve of PSV B. So that the operator can read from the tech plate what are the steps he has to execute.
Awesome. Okay, thanks, Stefan. Okay, so I think we're ready to close out. I think we've answered most of the questions or all the questions that were in the Q&A section. Sam, you're going to put up a survey just to see if anybody's interested in any more information and if we need to get in touch with anybody else.
An automated survey will pop up. You can fill it out if you like. One other thing to note, I will send out the recording and a follow-up email with resources. And if you require a certificate of attendance, I can get you that as well for your ongoing training.
Fantastic. Thanks, Sam. And again, thank you, Stefan. Thank you, Raj, for putting this on for us today and for everyone else to spend their time with us and hopefully have taken away something of value.
Right on.
Thank you.
Thank you very much for the invitation. And we are happy to get confronted with your challenges.
Awesome. Well put.
Thank you all.
Thanks all for attending.
Cheers.
Thank you. Bye.
Bye.